Hey guys, this is a problem solving video lesson on continuity. I hope you have seen my previous video lesson on limits. So in this video, as usual, I have some selected problems on continuity, therefore stay with me. Here, before I proceed to the problem solving, here I have to tell you some definitions and conditions for a continuity of a function at a point. Here, as you can see, continuous function at a point is defined in this way. A function f is said to be continuous at some point x0 if it satisfies these three conditions. One thing, this x0 should be the member of the domain. It should be an element of the domain of the function. The second condition is the limit of the function as x approaches to x0 should exist. Okay, the limit should exist means the second condition means the limit of f of x as x approaches to the number a, or here according to the given notation, the limit, we say the limit exists if the limit of f of x as x approaches to x0 from the right, and the limit of the function as x approaches to x0 from the left. If both these limits are the same, then we say that the limit exists. And the third condition is if the limit exists, the limit of f of x as x approaches to x0 is exactly the functional value at x0. So these are the conditions for a continuity of a function at a point. So based on this definition, I will show you the some selected problems on continuity. So here the first problem is we have a certain function f. For this given function, what is the value of a if this function is continuous at 1? So we will apply the definition that I showed you before to calculate the unknown constant a. So this is a piecewise function. For this function, what is given? The function is continuous at 1, meaning that the limit of the function as x approaches to 1 from the right, I mean from the left, is the same as the limit of the function as x approaches to 1 from the right. Okay, both left hand and right hand side limits must be the same so that the limit exists, and it should be the same as the functional value at 1. So this is shortly the condition for a continuity of the function. So we take the limits of this one. So the limit of this function is considered from the left of 1, or for any x less than or equals to 1, we consider the first expression. Therefore, the limit of f of x, meaning that a over x squared plus 1 as x approaches to 1 from the left, must be the same as the limit of x minus 1 over radical x minus 1 as x approaches to 1 from the right. So this must be true so that the function is continuous at 1. Now let us evaluate this limit. The limit of a over x squared plus 1 is a over, you can directly substitute x is equals to 1 here, a over 1 square plus 1. This is equals to, here you can't substitute 1 because the value becomes 0 over 0, therefore it requires some kind of simplification. So x minus 1 over radical x minus 1, we need to rationalize it by radical x plus 1 over radical x plus 1 as x approaches to 1 from the right. Then this must be the same as the limit of radical x plus 1 as x approaches to 1 from the right. Okay, this thing can be simplified into radical x plus 1, then this becomes 2. So this result becomes a over 2 is equals to 2 implies a is 4. You can use crisscross. A becomes 4. Therefore, the answer for this problem is a. So this function will be continuous whenever a is 4. That means for a different from 4, the function will not be continuous at 1. You can verify this thing in your own. The next problem is, this function is defined as 3 to the power of x plus k for x less than or equals to 0, or 3 times sine 2x over x for x greater than 0. So this function is continuous at 0, then what is the value of k? If this is continuous at 0, then what will be the value of k? So we will apply the condition for continuity at a point. That means we will evaluate the limit of f of x as x approaches to 0 from the left must be the same as the limit of f of x as x approaches to 0 from the right, which is again the same as the functional value at 0. So the left-hand side limit, for the left-hand side limit, we will take 3 to the power of x. So this becomes the limit of 3 to the power of x plus k as x approaches to 0 from the left. This is the same as the limit of 3 times sine 2x over x as x approaches to 0 from the right. Okay, so this must be the same as f of 0 using the condition for continuity at a point. So this implies here you can substitute 0 in place of x. So it becomes 1 plus k is equals to the limit of 3 times 2 times sine 2x over 2x as x approaches to 0 from the right. Here, I did something here. These two can be cancelled out. Then it remains the original one. But technically, you can make like this. So this is the same as 3 times 2 is 6. 6 times the limit of sine 2x over 2x as x approaches to 0 from the right. This is basically 1. So 6 times 1, which is 6. Now 1 plus k is equals to 6, implies k is 5. The value of k is 5, which means this function will be continuous at x is equals to 0 whenever k is 5. Let f of x is defined as a times sine x over x minus absolute value of x for x less than 0. And this function will be e to the power of minus x plus cos x for x greater than or equals to 0. Then if this function is continuous at 0, what will be the value of a? So such kind of problem is common in the case of continuity. So the only thing that you can do is apply the condition for continuity at a point, which is the limit of f of x as x approaches to the given point 0 from the left must be the same as the limit of f of x as x approaches to 0 from the right, which is again the same as the functional value. This is what we mean by continuity at 0. Therefore, now we can take the pieces of functions. For x approaching 0 from the right, from the left, we take the first one, the limit of a into sine x over x minus absolute value of x as x approaches to 0 from the left is the same as the limit of e to the power of minus x plus cos x as x approaches to 0 from the right side. So the whole this limit cos x at 0 is 1 and e to the power of minus x is here e to the power of minus 0 plus cos 0, which is 1 plus 1, which is exactly 2. The right hand side limit is 2. So this implies the limit of a times sine x over x minus, for x less than 0, for x approaching from the left of 0, we consider absolute value of x as the negative of x. As x approaches to 0 from the left, this must be the same as 2. So this again in turn gives us the limit of a times sine x over x plus x is 2x as x approaches to 0 from the left. Again, this can also be written as a times the limit of 2 times, I mean we can take out here I can take out a and 2, therefore it becomes a over 2 into the limit of sine x over x as x approaches to 0 from the left. This is the same as 2. Okay, but we know that the limit of sine x over x is 1. So this implies a over 2 times 1 is 2. So a over 2 times 1 is a over 2 itself, which is equals to 2. Now using crisscross, a times 1 is equals to 2 times 2, which is 4. Therefore, the value of a must be 4, so that this function will be continuous at x is equals to 0 whenever a is 4. Let f of x is a times sine 2x over x and e to the power of 2x minus 2 for different positive and negative x values. So this function is continuous at x is equals to 0. If this function is continuous at x is equals to 0, what is the value of a? So if you observe 3 examples, you can do this thing in your own. So the first step is we put the limit of f of x as x approaches to 0 from the left. This is the same as the limit of f of x as x approaches to 0 from the right, and which is f of 0. So we substitute the 2 pieces of the function, the limit of a into sine 2x over x as x approaches to 0 from the left is equals to the limit of e to the power of 2x minus 2 as x approaches to 0 from the right. Okay, so we need to be very technical here to solve this limit. So here I can make here 2, here 2, therefore I can take out this constant, so it can be written as 2a times the limit of sine 2x over 2x as x approaches to 0 from the left. This is the same as the limit of this one as x approaches to 0 from the right is e to the power of 2 times 0 minus 2, which is e to the power of 0 minus 2. Is any number to the power of 0 except 0 to the power of 0 is 1. 1 minus 2 is minus 1. So here 2a times the limit of this one is 1. 2a times 1 is equals to minus 1. So this is the same as 2a is equals to minus 1. Now you can divide both sides by 2. So this a value will be minus 1 over 2. So this function will be continuous at 0 whenever a is minus 1 over 2. Which one of the following is true about this function? Okay, the given function is our function is f of x is equals to x squared over x for any x different from 0, or 0 for x is equals to 0. So the function becomes 0 only whenever x is 0, otherwise x squared over x. So this can also be simplified to our function is x squared over x is x, but we take f of x is equals to x for x different from 0, and 0 for x is equals to 0. Therefore, this is our function. So if you see the graph of this function, it will be like this. It will be a straight line passing through the origin. Whenever x is 0, it becomes 0. For x greater than 0, it's y is equals to x. For x less than 0, y is equals to here. So this function is continuous everywhere. It's continuous everywhere, including 0. So which one of the following is true about this function? This function is continuous everywhere. What is the value of k? The value of k, so that this function is continuous at 0. So we will apply the technique that we have seen so far. So here the limit of f of x as x approaches to 0 from the left must be the same as the limit of f of x as x approaches to 0 from the right. You can take the functional value at 0. So we can substitute these pieces into their places. The limit of the function from the left of 0 means I will take k minus e to the power of 2x as x approaches to 0 from the left. This is the same as the limit of tan 2x over x as x approaches to 0 from the right. But here, I can do here, if I put 2 here, I can also put here 2. Without loss of generality, we can do like this, because these two can be cancelled out. Okay, it can be cancelled out. So taking these 2 here, I can write this expression like 2 times the limit of tan 2x over 2x as x approaches to 0 from the right. Now, this limit is 1. You can substitute 1 here. So this problem becomes k minus e to the power of 2 times 0 is equals to 2 times, here we have 2, this is 1, 2 times 1. Okay, so this becomes k minus e to the power of 0 is equals to 2. E to the power of 0 is 1. So k minus 1 is equals to 3. K minus 1 is equals to 2. Therefore, our k value becomes 3. So for k is equals to 3, this function will be continuous at x is equals to 0. Therefore, our answer is B. If f is continuous at x is equals to 0 and g of x is given, then g is a combination of some function and f. Then what is the value of the limit of this function, given that this f is continuous at 0? So to solve the limit of this, the limit of g of x as x approaches to 0 from the right, g of x means this one. So this means the limit of radical x into 2 times f of x plus 3 over radical x as x approaches to 0 from the right. You can distribute this radical x into the bracket. then it becomes the limit of 2 times radical x times f of x plus radical x times 3 over radical x is 3. Okay, we evaluate this as x approaches to 0 from the right. Now you can directly substitute 0. 2 times 0 times f of 0 plus 3. But radical 0 is 0, therefore the whole this thing becomes 0. So 0 plus 3 will be 3. So the limit of this function where f is continuous at 0 is 3. And the last problem regarding continuity is here. This function is a piecewise function which is defined in 3 different ways. We defined the function by x plus 1 for x less than 1. It will be ax plus b for x between 1 and 2, and we take 3x for x greater than or equals to 2. So what will be the value of a and b if this function is continuous everywhere? So there are 2 points in which this function is separated. One is at 1, the other is 2. So this function is defined in 3 different regions: for x greater than 2, for x between 1 and 2, for x less than 1. So to make this function continuous everywhere, we need to have this condition. The limit of this function f of x as x approaches to 1 from the left must be the same as the limit of the function as x approaches to 1 from the right. At the same time, this function must be continuous as x approaches to 2 from the left and the function from 2 from the right. Now this function will be continuous everywhere. So this means the limit of 1 from the left means x plus 1 as x approaches to 1 from the left. This must be the same as the limit of the function 1 from the right is ax plus b as x approaches to 1 from the right. Okay, this must be satisfied, and the limit of 2 from the left means ax plus b, ax plus b as x approaches to 2 from the left. This must be the same as the limit of the function 3x as x approaches to 2 from the right. Now it's very simple. Substitute x is equals to 1 here, then it becomes 2 is equals to, substitute 1 here, 2 is equals to a plus b. And the other, here we have one equation containing 2 unknowns, and substitute here 2, it becomes 2a plus b is equals to, substitute here 2, 3 times 2 is 6. We have another equation with 2 unknowns. So we can solve this using simultaneous equation. A plus b is 2 and 2a plus b is 6. So using elimination, you can multiply the first equation by -2, the first one, the second by 1. So this becomes minus 2a minus 2b is equals to -4. Then 2a plus b is equals to 6. Now adding them together, this becomes minus b is equals to 2. So b becomes -2. If b is -2, you can substitute here 2a minus 2 is equals to 6. 2a is equals to 8. Therefore our a value becomes 4. So a will be 4 and b will be -2, so that this function will be continuous everywhere. Therefore Our answer is A.